The sun, our life-giving star, a celestial inferno burning with unimaginable energy, has long held secrets that defy explanation. But now, NASA's Parker Solar Probe has ventured closer than ever before, uncovering shocking discoveries that could rewrite everything we thought we knew. Strange magnetic waves, invisible energy bursts, and mind-bending solar phenomena. Could these findings finally solve the mystery of the sun's scorching outer atmosphere? Or do they reveal something even more unsettling? As the Parker Solar Probe sends back data that leaves scientists stunned, one thing is certain: the sun is far more powerful and unpredictable than we ever imagined. For centuries, the sun has remained both a source of life and an enigma, a blazing inferno whose true nature we've only begun to understand. Now, NASA's Parker Solar Probe has shattered expectations with a discovery so profound that it could redefine our understanding of the star that governs our solar system. Traveling closer to the sun than any spacecraft in history, the probe has uncovered mysterious magnetic waves and bursts of invisible energy that defy existing scientific models. These revelations could explain long-standing cosmic puzzles, like why the sun's outer atmosphere is hotter than its surface, while raising urgent new questions about the raw, unpredictable power of our closest star. Could these findings reshape how we predict solar storms, protect our technology, and even safeguard our future in space? What the Parker Solar Probe has just uncovered is not only groundbreaking, it's a wake-up call. Launched in 2018, the Parker Solar Probe has been on a daring mission to touch the sun, venturing into the star's outer atmosphere to gather data that was once thought impossible to obtain. This spacecraft, the fastest human-made object in history, has just sent back groundbreaking information that has left scientists stunned. What it discovered in the sun's corona, a layer of the sun that has baffled researchers for decades, could rewrite everything we thought we knew about our star. A mission to touch the sun, like never before. For as long as humans have gazed up at the sky, the sun has been both a source of wonder and an untouchable force of nature. It fuels life on Earth, drives our climate, and powers everything from plant growth to ocean currents. Yet, despite its importance, the sun remains one of the greatest cosmic mysteries. Scientists have spent centuries studying its fiery surface, its swirling magnetic fields, and the powerful solar storms that can wreak havoc on Earth's technology. But one question has baffled researchers for decades: why is the sun's corona, the outermost layer of its atmosphere, hundreds of times hotter than its surface? To answer this, NASA launched the Parker Solar Probe in 2018, an audacious mission to touch the sun by flying closer than any spacecraft before it. This cutting-edge probe, equipped with revolutionary heat shields and high-tech instruments, has since been venturing through the sun's harsh environment, collecting data that was once thought impossible to obtain. The Parker Solar Probe has become the fastest human-made object in history, hurtling through space at speeds of nearly 700,000 kilometers per hour, 430,000 miles per hour. And now, it has sent back information so shocking that it has left scientists rethinking everything they knew about our star. The data reveals unexpected magnetic waves, bursts of invisible energy, and strange zigzagging patterns in the sun's magnetic field, phenomena that could finally explain why the sun's outer atmosphere burns at millions of degrees. These findings could not only change our fundamental understanding of solar physics, but also help us predict and prepare for space weather events that could impact satellites, power grids, and even future space missions. With each daring approach, the Parker Solar Probe is peeling back the layers of solar mystery, unlocking secrets that could shape the future of space exploration and our survival on Earth. But what do these latest discoveries truly mean? And could they reveal that the sun is far more unpredictable than we ever imagined? As the probe continues its journey, one thing is certain: we are only beginning to scratch the surface of the sun's hidden power. the mission of a lifetime. The Parker Solar Probe is no ordinary spacecraft. Named after Dr. Eugene Parker, the astrophysicist who first theorized the existence of solar wind in the 1950s, this probe is designed to withstand the sun's extreme environment. It's equipped with a cutting-edge heat shield made of carbon composite material, capable of enduring temperatures up to 1,370 degrees Celsius, 2,500 degrees Fahrenheit. This shield allows the probe to fly within 4 million miles of the sun's surface, closer than any spacecraft in history. But why go through all this trouble? The sun is the heart of our solar system, the source of light, heat, and energy that makes life on Earth possible. Yet, despite its importance, there's still so much we don't understand about it. For instance, why is the sun's corona, the outermost layer of its atmosphere, so much hotter than its surface? How do solar winds, the streams of charged particles flowing from the sun, accelerate to such incredible speeds? And what drives the powerful magnetic forces that shape space weather, affecting everything from satellites to power grids on Earth? These are the questions the Parker Solar Probe was designed to answer. But what it found was something far more unexpected and, potentially, revolutionary. The discovery that changed everything. As the Parker Solar Probe plunged deeper into the sun's corona, it began detecting strange magnetic waves, unlike anything scientists had ever observed. These waves weren't just minor disturbances. They appeared to be influencing the movement of solar material in ways that defied existing models. Even more shocking, the probe recorded invisible bursts of energy, intense surges of power that seemed to appear and disappear within fractions of a second. These findings could finally explain why the corona burns so much hotter than the sun's surface. For decades, scientists have theorized that magnetic waves or hidden energy bursts might be responsible for this phenomenon, but until now, there was no direct evidence to support these ideas. The Parker Solar Probe's data suggests that these mysterious magnetic waves and energy bursts could be the missing piece of the puzzle. But that's not all. The probe also detected something called switchbacks, strange zigzag patterns in the sun's magnetic field. These sudden reversals, never seen this close to the sun before, seem to be linked to massive bursts of energy. If confirmed, this discovery could reshape our entire understanding of how the sun's energy moves through the solar system. What does this mean for us? The implications of these discoveries are profound, not just for scientists, but for everyone on Earth. The sun's activity has a direct impact on our planet, from the auroras that light up our skies to the solar storms that can disrupt satellites, knock out power grids, and even affect radio communications. Understanding the sun's behavior more precisely could allow us to predict these events more accurately, giving us time to protect our technology and infrastructure. But there's a catch. The Parker Solar Probe's findings suggest that the sun's corona behaves in ways we still don't fully understand. This raises a disturbing question. Have we been underestimating the true power of our star? If so, what does this mean for the future of space exploration and for life on Earth? The future of solar exploration. The Parker Solar Probe is far from finished. Over the next few years, it will continue its mission, flying even closer to the sun and gathering more data. Each approach will allow scientists to collect even more detailed information on solar winds, magnetic fields, and high-energy phenomena that have remained a mystery for centuries. But these discoveries may be just the beginning. The unexpected magnetic waves and energy bursts detected so far suggest that even greater solar mysteries could be waiting to be uncovered. Scientists are now preparing for future observations that could confirm whether the sun's corona operates under completely unknown physical mechanisms. Meanwhile, back on Earth, the implications of these findings are already shaping the future of space weather forecasting. NASA and other research institutions are updating their models to incorporate the Parker Solar Probe's latest discoveries. Understanding the sun's behavior more precisely could allow for early warnings about solar storms that threaten satellites, power grids, and astronauts in deep space. A new era of solar science. The Parker Solar Probe has just uncovered unexpected solar activity that is forcing scientists to rethink everything they thought they knew about the sun. From strange magnetic waves to powerful bursts of invisible energy, these discoveries are reshaping our understanding of how the sun operates and how its unpredictable behavior could impact Earth. These findings could revolutionize solar storm predictions, improve space weather forecasting, and even change how we prepare for future space missions. But with each new discovery, more questions emerge. How much more powerful is the sun than we ever imagined? Could its activity be far more chaotic than we realized? And most importantly, what other secrets is it still hiding? Utro, a new era of solar science begins. The Parker Solar Probe's mission is far from over, yet it has already changed everything we thought we knew about the sun. From detecting strange magnetic waves to observing bursts of invisible energy within the corona, this groundbreaking spacecraft is unraveling the deepest mysteries of our star. These discoveries aren't just theoretical, they could have real-world consequences for space travel, satellite technology, and even life on Earth itself. For decades, scientists have struggled to explain why the sun's outer atmosphere is millions of degrees hotter than its surface. Now, thanks to the Parker Solar Probe, we finally have clues pointing to powerful, unseen forces shaping the sun's energy. If we can understand these forces, we may one day predict solar storms with pinpoint accuracy, safeguarding power grids, communication systems, and astronauts in deep space. The data from the probe is already being used to refine space weather models, which could be crucial for future missions to the Moon, Mars, and beyond. But perhaps the most exciting part? The Parker Solar Probe is just getting started. With each daring approach, it will fly even closer to the sun, venturing deeper into the corona, where more secrets are waiting to be uncovered. What new surprises will it reveal? Could it discover unknown mechanisms of energy transfer, or even phenomena that challenge our understanding of physics? One thing is certain: the sun is more complex, more powerful, and more unpredictable than we ever imagined. And as the Parker Solar Probe continues its mission, the discoveries it makes could shape not only our knowledge of the sun, but the future of space exploration itself. So, as we eagerly await the next set of findings, one question remains: what else is the sun hiding? Stay tuned, because the most astonishing revelations may still be ahead.